Hey judges, this season we focused on improving our robot pathing and drivetrain movements during our autonomous period. Using cameras and sensors allowed us to direct the robot's movements throughout the autonomous period, and building as many automated functions as possible into the teleop period to reduce stress on the driver and simplify robot controls on our scoring mechanisms. Using a Java pathing library called Roadrunner enabled us to generate trajectories and translate them into motor velocities using a closed-loop PIDF controller. This allows for real-time adjustments to the robot's pathing using data from the drive encoders. We specify the trajectories in Java using Roadrunner, and these trajectories are then plugged into reverse kinematic equations to extrapolate target velocities for each motor. These velocities are led into the PIDF controller, and the heading is controlled independently of the X and Y position of the robot on the field based on the heading data from the built-in gyro on the control hub. This season, we also implemented the OpenCV Java computer vision library to help us track our team shipping element during the autonomous period. Our team shipping element is bright yellow to distinguish the team shipping element from its surroundings. We converted the incoming video frames from RGB to the YCRCB color space. This allowed us to separate the intensity of color from the colors themselves. We then separated the incoming image data into three different sub-matrices, each representing a region where the team shipping element might be, so left, middle, and right. We extracted the intensity data from these frames and used matrix algebra to determine which of the three possible regions had the highest average intensity value. And our team shipping element is bright yellow, as stated earlier. The sub-matrix with the highest intensity is the one with our team shipping element. We also use a color sensor to detect when freight is occupying our scoring mechanism. This was useful during the autonomous period to detect when to return to the shipping hub. Originally, we had two drivers operating the robot, one operating the drivetrain, and one directing our scoring mechanism. However, we found this approach to be very inefficient and uncoordinated, and we switched to condensing all controls to one gamepad with one driver. We greatly condensed the functions of our slide mechanism so that all functionality could be controlled with four buttons, A, B, X, and Y. B, X, and Y extend the slide to a given level, Y being the highest level, X being the lowest. Pressing the same button dumps the freight at the specified height, while pressing A retracts the entire mechanism. We found these controls to be very intuitive and efficient. In addition, we created an automated function for our duck mechanism. We press any of the D-pad buttons as shown here, and it automatically spins the duck mechanism, going slow at the beginning and then increasing speed over time. Thank you for your time and good luck to all the teams.